All right, so this is going to be 3.5 part 1. And today we're starting a conversation that is super important moving forward. Transformations of functions. Transformations of functions is the name of today's lesson. This is 3.5. And this is going to be part 1. All week long, we're going to be talking about transformations of functions. Your next test will cover 3.4, the composition of functions that we just took the homework paper over. It'll cover that lesson and then the lessons that go 3.5 this week, and then we'll be done. Okay, so I won't add on any more to it than what we cover in this particular section. It's a big one. And so for today, in part 1, we're talking about vertical and horizontal shifts. Vertical and horizontal shifts. Okay, when you were in 8th grade math, you had images, right? I think that I taught 8th grade math a couple of times. You had an image like this, and you would have to shift it left, down, right, diagonal, right? Other transformations that we could do on this kind of function, you could reflect it. Do you remember reflecting it, flipping it over the x-axis? You could also do a dilation of that function. Okay, we're kind of doing the same thing, but instead of shapes, we're dealing with actual functions. Cool? All right, so for today, only shifts, not reflections, not rotations, not dilations, not anything else, just translating, left, right, up, down. Okay, and so for vertical shift, what we have is vertical shift. What you have is a new function g of x. And g of x is found by taking the old function f of x and adding k, f of x plus k. Take the old function and translate it. Okay? If that k value is positive, your function is going to go up k units. And if k is negative, we expect that function to go down k units. Okay? Really, really straightforward here. Nothing scary. All right, so I want to look at an example. This is going to be example 1. And the function we're going to look at is f of x equals x. So the most straightforward function that you know of. This is the identity function. What does it look like on a graph? F of x equals x. It's linear, goes through the origin, has a slope of 1. Rise 1, run 1. Rise 1, run 1. Cool. So I'm graphing this guy. He should be an old familiar friend. By this point, you should recognize this function with everything in you. Okay. Now we're going to graph 2 new functions. The first one we're going to graph is going to be g of x, which is going to be f of x, or x, plus 3. G of x equals f of x plus 3, or x plus 3. So I'm going to take this old function, and we're going to slide it up. Every single point gets moved up 3 units. Really just click and drag. Can you see? Okay. And we can do the same thing here. We can graph a function h of x, and let's let it be x what? What do you want it to say? X minus 2. Perfect. x minus 2. So I'm going to take my parent function, or my identity function, f of x equals x, and we're going to drop every point down 2 units. Drop every point down 2 units. Any questions here? On this lesson, you're going to have to recall those toolkit functions. Okay, they need to be at the front of your little brains so that you can come up with them really quickly. Everybody got vertical shift? Up, down, up, down, up, down. No problems here? Okay. Are y'all ready to move on? Okay. Next is going to be horizontal shift. Horizontal shift. And this function, the new one, g, is going to be in the form of f of x minus h. F of x minus h. And notice that that h is inside the parentheses with x. Okay. Used to, when I was corny back in the day, I would teach my kids that k stood for vertical with a K, and H stands for horizontal with an H. Aren't y'all glad I'm not corny anymore? No, quit that. Okay, H for horizontal. And so let's look at example 2. Let's just dive in here and see if we can come up with what's happening. On example 2, it says graph f of x equals x squared. So this is our old familiar friend, the parabola. And we can graph it by inputting and outputting some numbers. If I input 0, what is 0 squared? 0. What is 1 squared? What is 2 squared? Okay. And on the left side, if I input -1, what is output? Also 1. And if I input -2, what is output? So this is this pretty little U-shaped function that bounces off the x-axis. Yeah? Okay. Next, we're going to graph g of x. And g of x is going to be in parentheses x plus 3, close parentheses, squared. Let's do x minus 3, actually. Let it be x minus 3. In parentheses, x minus 3, close parentheses, squared. Okay? And now I want to set you up for a little scenario. You have been in lunch, right? And after lunch, you go to the playground where the recess happens. Everybody got it? Yeah? Okay. Well, Tate happened to bring his lunch to school. And in Tate's lunchbox, his mother packed him the very best cookies of all time. Right? Okay. And Jaden and Bryson happened to know that those cookies are in there. And so they all go out to recess, and life is good. And Tate hadn't eaten them all. So he leaves his lunchbox unattended at the playground. So what do you think happens? Well, yeah, they did. These two boys know that lunchbox has the cookies, the best cookies, right? So they rate it, and they eat them. And Maddie happens to be standing there, and she's watching the whole thing, and she's thinking, if they shared with me, this might go differently. But they did not share with her, right? So Tate comes back to his lunchbox at the end of recess. He finds that his lunchbox has been raided. There are no more cookies. And he looks around and he tells the teacher, hey, somebody ate my cookies, and these were my mama's cookies. They're the good ones, and I don't know what to do now. And the teacher pulls aside Jaden and Bryson, and she says, what happened? What happened to these cookies? And these two boys say what? What do they say? You say Bryson ate them? Bryson says Jaden ate them. Neither one of you fess up with the real story, right? But then there's little old Maddie. And Maddie's standing by the wayside, and she saw the whole thing. What does she say? She said, they stole them. I watched the whole thing happen, and they didn't share, so I'm about to snitch. Right? Okay? Here's the moral of this story. And if you take anything away from that, I want you to write this down. Insiders lie. Insiders lie. This is going to be the story from now through calculus. Insiders lie. Outsiders tell the truth. Insiders lie. Outsiders tell the truth. So if you're on the inside and you actually partook in the stealing of the cookies, you are going to lie your way out of that all day long. If you were on the outside and you watched it go down and you didn't get any cookies from it, you're going to snitch. You're going to tell exactly what happened. Okay, so I want you to look at this g of x sentence. Can you see where this -3 or the 3 is located in this equation? Can you tell that it's inside with x? Can you see that? Yeah. It's located inside the function, inside with the x. This is a liar. If it says x minus 3, you feel like if this is a horizontal shift, it should shift to the left. In actuality, it shifts to the right because insiders lie. Okay, so this is going to be a shift right 3 units. Because of its location, it's located inside with the x variable. So when we draw g of x, we're going to take our f of x function and we're going to pop it to the right 3 units. 1, 2, 3. And we'll plot all these new points. Kind of drag and drop. 1, 2, 3. Move to the right. 1, 2, 3. Everything gets shifted right 3. And the reason for that is, in this original function up here, it's written as f minus h, x minus h. So the h is actually the 3. The 3 says go right. Right? If it was plus 3, it would have been h was a -3. Minus a negative would have made the positive. Okay? That gets real confusing and really easy to forget. So what I would remember if I were you is insiders lie, outsiders tell the truth. Okay? And you can test this. Let's try to plot what is y when x equals 3. What is y? If I input 3 right here for x, what's g of 3? 3 minus 3 is 0. See? 0. Okay? If I input 4, what's 4 minus 3? 1. 1 squared is... So if I input 4, I should output 1. Do you see that it works? Okay. One more. Let's graph h of x equals x plus 2 group squared. H of x equals x plus 2 squared. So now, where am I going to drag and drop this guy? 2 to the left. Left 2. Your original function, left 2. Oh, that was terrible. Now then, any questions on that, y'all? No? Okay. All right, so I'm going to write a new function here. This is example 3. And let's see, I want it to be located here. And I want it to be, boom. What's the equation? First of all, do you recognize the kind of function that it is? It's absolute value. Good. This is your toolkit function, absolute value. And what has happened to this absolute value function? Which way? To the right 2. Shifted to the right 2. So now, remember, horizontals are inside. Insiders are horizontal. So how could we write this function? Let's call it g of x equals absolute value of x minus 2. Perfect. Absolute value of x minus 2. Insiders lie. So if it went to the right 2, it's x minus 2. No questions here? Okay. Why is it not absolute value of x? Okay. Not like this. Why not? Not to the left. Where would that one have gone? Down. Down. That 2 would have been an outsider. Okay. That function would have looked like this. Okay. All right. New topic. This is example 4. Okay. What about this? What's the equation of this guy? Oh, square root. Good. This is a toolkit function. This is f of x equals square root x would have been your toolkit function. F of x equals the square root of x, which should have looked something like this. Right? But what has happened is that function has been moved. So what's my g of x function? Where'd it go? Where is it? X what? X minus 3. Very good. How do you know that, Maddie? It shifted horizontally to the right 3 times. And let me put some tick marks there so you can see. What else? Plus 2. Good. The outsider here is going to be up 2. Outsiders tell the truth. Insiders lie. Outsiders tell the truth. Perfect. So what's the domain of this new g of x function? How far left to right? Positive 3 to positive infinity. Very good. A lot of you missed the square bracket on your test. Y'all didn't catch that it had to be a square bracket right here. What's the range of this new function? 2 to infinity. Range is the y values. How about it, guys? We feel like we did okay here? Okay. All right. Let's try a few. Let's let this be example 5. Example 5. And your job is to graph f of x equals the absolute value of x plus 1 minus 3. Absolute value of x plus 1 minus 3. Anybody got any tips? I do. I have tips. What I would do first if I were you. First I would draw an axis that was somewhat straight. There we go. I would draw your parent function first. I typically like to see that toolkit function before I translate it. So I'm just in my little head plotting some points here that I can use to translate. Then from that, I follow these rules. What's this one going to do? Where's it going? Left how many?
1.
Left 1. Okay, and then what?
Down. Then you go up. No, you go down.
Down 3. So left 1, down 3. There's my new origin, or my new vertex. Left 1, down 3. What is it, Patri?
Like the original one, this is greater like that.
Huh?
It doesn't matter what your function.
Yeah. The original one, this is f of x equals absolute value of x. And so then I have some points that I can actually translate. Left 1, down 3. Left 1, down 3. Look. Oh, I missed. There's my new function. Any questions on this one, guys? No? Okay. Some of y'all are feeling very sleepy, so I'm about to give you a really good one to try. This is the last problem that we're going to work today. This is the try it. Okay. We're going to envision that this is the reciprocal function. Okay, what does the reciprocal function say? F of x equals 1 over x. Okay, we want to write an equation that takes this function, and I want you to remember what this function looks like. It has an asymptote, and we'll learn what that means later, at 0, because I cannot divide by 0. So when x equals 0, this one breaks. Because it can't equal 0 in x, it also never equals 0 in y. And so what we see are two branches that look like this. Yeah? That's your toolkit function for the reciprocal function. Now, we're going to write an equation for a new function that shifts the toolkit function 1 unit to the right, 1 unit to the right, and 3 units up. We want to shift the toolkit function 1 unit to the right and 3 units up. So this will be a new equation, g of x equals. One unit to the right. How? Yes. 1 over x minus 1. So it's an insider. It's got to lie, and it needs to go with x in the denominator. And then where are you going to put the 3 units up? Outside. Plus 3. Let it tell the truth. Okay. So instead of having this boundary that it can't cross at 0, now that boundary is shifted 1 over. It's going to be here. And then instead of having the horizontal boundary at y equals 0, where's it going to go? Up 3. So my new horizontal line that it doesn't cross is going to be up here. So where's that new function located? In this area and in this area. So we still took the reciprocal function and we drag and drop. And now it has a new location. Okay. The moral of this story, guys, is insiders lie, outsiders tell the truth. You are going to need to graph in your homework, just little sketches. Okay, don't make anything too complicated. If you look at mine here, you can see, like, I graphed and I plotted points and it's precise, but it's not having to be on a large scale graph paper. Okay. Any questions on this lesson at all? No? Think you got it? All right. If you want to hold off on your homework, I'm going to let you have a whole work day on Wednesday.
But I have to do this.
That's the last 10 minutes.